I'm honored to participate in this conference, and I'd like to thank the organizers for inviting me. I'm going to talk about SARS-CoV-2 vaccines. Our main objectives, we are going to review the most common vaccine that being used in the GCC in terms of platforms, effectiveness, and safety. Now, it's very important to know how the vaccine is developed. So I think most of you know by now that before we start any clinical trials, there's two important steps, drug discovery and the preclinical. And drug discovery actually preceded by another phase, which is pre-drug discovery, where they have to understand the disease. During the drug discovery or vaccine discovery, they try to understand the target and the molecule, which molecule they will choose. Preclinical, it's the animal testing for the vaccine. Then the typical three phases, phase 1, 2, and 3. The number increased with between the phases. Phase 1, the number relatively small. Phase 2, a few hundreds. Phase 3, usually in thousands. And most of the time, if it is a vaccine, it is like more than 30,000. And then that followed by registration and authorization, manufacturing and marketing. And then after that, there's something called post-authorization or phase 4 or post-marketing. Now, during different phases, we do monitor the safety and the efficacy or effectiveness. So in the initial phases, the focus is mostly on safety and immunogenicity during the preclinical and phase 1. Phase 2, we continue to monitor safety and immunogenicity, but we'd like to have a proof of concept and decide on the dose. Phase 3, you will measure the efficacy. Now, the efficacy is the difference between the control arm, which usually placebo, and the intervention arm, which is usually the vaccine in case of vaccine trial. Of course, again, during this time, we monitor safety and immunogenicity. After approval, we continue to measure the safety, and instead of efficacy, we call it effectiveness of the vaccine, and we see if there's any new indications for the vaccine. Plus, in terms of how we monitor that, during the trials, we monitor local and systemic side effect, adverse event, and serious adverse event, while after marketing, pharmacovigilance will monitor the safety and the side effects of the vaccine. Now, to develop a vaccine, it takes many years. Typically, it can be up to 10 years. Now you will say, well, what happened with SARS-CoV-2? Did they skip any of the phases? Actually, no, they didn't. They did all the phases, but what happened? There was a lot of support from different government, different leadership, different organization, lots of funds. Everyone is working toward identifying the target and then identify the vaccine or the molecule. So there was a lot of overlap between the phases, but every vaccine that been approved by the WHO went through all the phases. Now, currently, there are 10 vaccines that are approved by the WHO. We'll start with the vaccine platform so you can understand the vaccines more. Our first one is the mRNA vaccines. Now, mRNA, it consists of mRNA encoding target gene, and once it's administered, it's translated into target protein, and that elicits immune response. So basically, it's like a messenger RNA where it will teach the cells how to form antibodies. Good examples is the Pfizer vaccine and the Moderna. Do we have any examples from the past? No, that was the first approved vaccine, but they've been working on the mRNA for over 10 years now. But the two successful vaccines are the Pfizer and Moderna. Now, remember, mRNA remains inside the cytoplasm. It does not enter the nucleus and does not interact with or integrate into recipient DNA. The other platform is the vector virus vaccine. And here they use different virus, not the SARS-CoV virus, as a vector or as a carrier. And viral vector has been engineered not to replicate. So once the viral vector inside our body, it's not going to replicate. There are different examples. This is a very popular platform. So the known one is three, Johnson & Johnson, AstraZeneca, and Sputnik. There is also CanSino. There was another vaccine, not only COVID vaccine, used this platform, which is Ebola virus vaccine. This form is well known and been used for many years. It's called inactivated vaccine. Basically, they culture the virus, and the virus go through chemical inactivation, and then it's combined with adjuvant to stimulate the immune response. Good example, Sinopharm vaccine, also Sinovac vaccine, and another vaccine called Covaxin. Other vaccine examples from the past is inactivated poliovirus vaccine. Then there is the recombinant vaccine. Recombinant vaccine is composed of a purified viral protein that have been expressed in one of the various systems. And again, this is a well-known technology used for human papillomavirus, used for hepatitis B vaccine. Good example is Novavax. Also Sinopharm now. They have the recombinant protein vaccines at different stages of clinical trial, and it stimulates the immunity to the purified viral protein. I'd like to give you an overview of those vaccines. So starting with Pfizer, it is an mRNA. It is authorized for use in person 5 years and above. And primary, they approved 2 doses. For adults, there is for those above 12 years. For those below 12 years, the dose is like 1/3 instead of 30 microgram. It is 10 microgram. Third dose in the last few months was recommended for certain group and in some countries for everybody. And the efficacy during phase 3 was 95%. Another example of mRNA vaccine is the Moderna vaccine. And the dose is much higher. It is 100 microgram, 4 weeks apart. It is authorized for those who are above 12. And initially it was 2 doses, 28 or more in between. And the booster dose, the dose is less. Instead of 100, it is 50 microgram. It can be given after any of the mRNA, including Moderna, and also it can be given after Johnson & Johnson. And the reported efficacy is similar to Pfizer, it was in Pfizer 95, and this is 94%. Then we have AstraZeneca. It is adenovirus vector vaccine, authorized for those who are above 18, and administered as 2 doses, duration 4 to 12, and the efficacy is 70%. Johnson & Johnson, the technology is similar to AstraZeneca, and the primary was only 1 single dose. Recently, CDC approved a booster dose, and the reported vaccine efficacy is 66%. The Beijing or Sinopharm inactivated vaccine, it's approved for those 18 years and above. The primary series was 2 doses, and part of phase 3, we conducted a booster dose and approved to be effective in boosting the immunity. So now it is recommended to give a booster dose, and the efficacy during the trial was 78%. Now, if we look at all the vaccines, this is here mainly the vaccines that are approved in US, which is mRNA and adenovirus vectors. All the vaccine effectiveness decreased over time. And this is expected if you are using a vaccine against an mRNA, against an RNA virus that continuously mutate. The good things is the effectiveness against hospitalization, although decreased, but it is not as, it didn't decrease as much as the effectiveness against infection or symptomatic infection. This is again, if you in US, it compared those who are fully vaccinated with booster versus those who are not vaccinated. So those who are fully vaccinated, the risk of testing positive, not vaccinated, the risk of testing positive 13 times compared to fully vaccinated with booster, and the risk of dying is 68 times. This is interesting slide. It showed the difference in effectiveness if you modify the duration between the two doses. So once you increase the duration, the effectiveness improved for the mRNA. England also showed the same finding. With increasing the doses more than 6 weeks, the effectiveness is better than the standard dose, which is 3 to 4 weeks. I'll skip this part. What about the effectiveness against long COVID? So there are multiple studies showed that actually the vaccine did not only prevent minimize the hospitalization and death and ICU, but it also decreased the long COVID, even for those who got the infection but was vaccinated. In terms of the impact of the vaccine efficacy against the different variants, now several variants with potential for immune escape have been identified worldwide. And the vaccine effectiveness, especially when we start to see Delta, it reduced overall, but retain against the severe disease. Now, with Omicron, unfortunately, all the effectiveness among all the platforms decreased. However, with the booster, we start to see a prevention against hospitalization, death, and critical care. I'd like to discuss now the safety. So we'll start with the symptoms or the common side effects. Common side effects, locally, redness, soreness, and swelling, generally chills, fatigue, joint pain, headache, mild fever, muscle ache. There is some allergic reaction, which is possible with any vaccine. It can include anything, but the most serious, and it is rare, anaphylaxis. So this is maybe one of the only contraindication to the second or booster dose if someone develop anaphylaxis because of any of the vaccine component. There's something called stress-related reaction. Now, everyone should be aware of stress-related reaction. This have nothing to do with the vaccine. It is related to the anxiety and people being anxious. So they could turn pale, start to sweat, feel dizzy, tingling, start to breathe very quickly. Sometimes they feel a loss of sensation on their face, hands, or feet. And in children, we've seen breath holding spells. This is relatively common and very easy to manage. And you have to reassure the individual that this is not related to the vaccine itself. I'd like to discuss with you some of the rare reactions that have been reported. First one is myocarditis and pericarditis. Now, it's been reported due to mRNA vaccine and VARS. This is the system that's been used in US for reporting, detect over 2,000 preliminary report myocarditis or pericarditis. And most cases was after receiving Pfizer or Moderna, especially in male adolescents and young adults. However, they did good evaluation, and always they, this is from the CDC, from the Clinician Outreach Community Activities, COCA, which monitor and do proper studies for vaccine safety. If you look at the benefit versus the risk for both Moderna and Pfizer, so, and specifically in this age group, 18 to 39. So if you prevent hospitalization, over almost 3,000 hospitalization, the cases of myocarditis you might see is about 33. With the Pfizer, you could prevent around also 3,000, 2,800. You will prevent. You will see 24 cases of myocarditis, and most of those myocarditis are self-limited, more than 90%. So here clearly the benefit outweigh the risk. This interesting study, this done in Canada, and they've looked at different combination and different duration. So if you give Pfizer followed by Pfizer, and you increase the duration to 8 weeks and above, the risk is extremely, extremely low. If you give Moderna, the risk is higher because the dose is higher. However, you could decrease the risk by increasing the duration. So as you can see, 4 weeks is more than 8 weeks. Now, the combination of Pfizer and Moderna, for reason that is not very clear, it increases the risk of myocarditis. Again, you could decrease the risk in case you give 2 different vaccines by increasing the duration. Another serious side effect is thrombosis with thrombocytopenia syndrome. This being reported after J&J Johnson, and in US they give around 18.5 million doses, and they identify only 59 cases of TTS. Now, the TTS overall reporting, it is 3.83 per million, and the highest are among females between 30 to 39. And there was about 9 TTS deaths, and the rate about 0.57 per million. If you look at the benefit versus the risk after Johnson and J&J COVID vaccine, again, the benefit outweigh the risk. Now, what about AstraZeneca? As it, more or less, it is a similar platform. So Europe report about 10 cases per million, and most cases initially was in women. However, they did change the product information by removing the previous statement, simply because with continuous monitoring, they identify 43% of the cases was among males and 37% among females, more than 60 years of age. So not only those who are young, yes, those who are young, maybe females more, but above 60, you can still see it. Another rare GBS have been identified after J&J, and in terms of the risk is still considered rare. However, if you compare it with other vaccines, this GBS was 11 times higher following J&J. And the analysis, they found no increased risk of GBS after Pfizer or Moderna. So I can say, in summary, COVID vaccines are safe and effective. And COVID-19 vaccine have been a critical tool in this pandemic and to prevent millions and millions of cases of hospitalization and death. Yes, with the Omicron, I think clearly the infection rate is very high, but as you can see in the country that have very high vaccination rate, they did not suffer, and alhamdulillah, most of the GCC vaccination rate is quite high, and we did not suffer from Omicron hospitalization or death. And I think many countries start to open up. However, my advice to everybody is even if we open up, there are certain preventive measures that we should continue, and we should maintain the vaccination. Thank you so much.